Tino. Starting. Yeah, we'll start. Now, some of the note is fine, no? Right. So, guys, we are starting. I hope the final part. Can't say exactly, but we'll see. Yeah? We have only like few things to go. Where is it? We discussed these things, right? Primers and everything. Second final quote. This is all done, right? Only the biodiesel is left to discuss, right? Right. So, what are the biodiesels? So the biodiesels. What do you know like about biodiesel? Like, what have you heard? Huh? It's a biofuel. Yeah. Yeah. And it was proposed for what? It was proposed to replace the the crude oils, which are the what do you call the crude oils? These petroleum oils, right? So, and that's the biggest lie in the history, right? Because like they propose it to replace the this petroleum fuels, because this is made of the oils, right? But when it comes to the the production part, when it comes to the deep theories, it's still depending on the crude oils. You'll understand that even the this biodiesel is completely depending on the the crude oils, which are the petroleum oils. So it's not gonna be a replacement anyways, and whatsoever, like so like now their like suggestion is this is sustainable. How does it become sustainable? How is the biodiesel sustainable? Can anyone tell?
Using already used kitchen waste, like the oils. You like it's under the 3 hours for the use.
Yes, not like
from plants, so it can be reused.
yeah, that is the thing. Now, the sustainable means you can reproduce it within a certain period of time, that it will not cost any of the imbalances of the cycle. Because when it comes to petroleum, the crude gases, it makes so many imbalances, like the carbon dioxide imbalance happen because of the crude oils, right? And it caused global warming. But and it ends someday, like they proposing it will end in 2050. The crude oil reservoirs will finish by 2050. That's what they're suggesting, right? Now the plant oils are there. Now their sustainability is this. Now if you use the biodiesels, that's basically the vegetable oils, right? So you are making the biodiesel using the vegetable oils. So what happens when you use the vegetable oils and when you burn it? The carbon dioxide it will anyway produce, right? But that carbon dioxide is again used to increase the biomass of a plant, because let's say a small plant is there, so it's taking all the carbon dioxide to photosynthesize, and they are making the biomass, which are the carbohydrate, proteins and lipids and sort of everything. Basically the photosynthesis makes the carbohydrates, and the carbohydrates are converted into proteins, lipids and everything inside the plant body. So the complete biomass of a plant when it's growing is made of the carbon dioxide it absorbs. Do you understand that? Did you think that it's the soil or something else? No, right? It's not the soil or anything else. The biomass of a complete plant from the small to the higher one is completely the tons of carbon dioxide absorbed. Do you all know that? Because the carbon dioxide is like converted into the carbohydrates, right? And the biomass is that, and that biomass is converted into proteins and lipid and everything, and all the other structures are made. So if a plant is growing, that means the tons of carbon dioxide are absorbed, right? So when you emit when you emit the carbon dioxide gas burning the biodiesel, that carbon dioxide again will be reabsorbed into the plants when it's growing and producing its biomass, and that biomass again converts into the vegetable oils, and that vegetable oil is used to produce the biodiesel. That biodiesel again burns, carbon dioxide produces, carbon dioxide used to grow the plants, again used to make the oils that can be recycled, right? That can be recycled, so that's sustainable, right? Can be reused. So that was their proposal, right? But when it comes to the real case, it doesn't happen that way, right? You understand when you are discussing it, right? Doesn't happen that way though, right? And the other thing is, there are so many issues when it comes to the biodiesel. Like people are like the world is having issues. Like what? Like the soil crisis is coming. In 2050, people are discussing, like the scientists are discussing, there will be a soil crisis. That means like the soil that can be used for agriculture is lacking, and it goes out of the nutrients, right? So by 2050, they are like calling there will be a soil crisis, that the soil that can be used for agriculture will be less, and the soil culture, sorry, the soil crisis leads to a food crisis, and there will be issues by 2050. So then now there's an issue. What? So there's limited ground or limited area to grow the agricultural foods, right? So and then now they are trying to grow the vegetables or the whatsoever the plants to produce the biodiesels. Like, is there enough space? No, even we don't have enough food to eat. Now they are trying to make fuels out of it, right? We don't even have enough food to eat, right? And they are now trying to make the fuels out of it. Would it help? No. So it's not gonna work anyways. So the biodiesel is proposed as a replacement of the crude oils. That's not gonna happen the way that, right? So, but we are learning it. Under the topic, we are learning it, and it's given. Now this is not the actual fuel that should be replaced. It should be something far more clean. One way it should be really clean. Now making biodiesel is not really clean. It's a long process, takes many things. It's not clean, right? Like if an energy source is to come, it should be really clean. Now the highest energy source now we have is nuclear, which is clean, but the issue is, yeah, the nuclear waste, and when it exposed to the environment, it's really harsh, can't tolerate to the people, and many of the troubles will cause, right? So something that doesn't cause any of the troubles like that, same like the nuclear, but not causing any of the harms like the cancer, sadhana, humanity, sort of energy source. If you found, and that's the turning point of the next era will be. So if you found it, you're gonna be the richest person in the world, ever will be, definitely for sure. You will be the richest person ever will be, for maybe 100 to 200 years, for sure. So try to find one, right? So the biodiesel, right? Where's the pen? No, make a one, maybe. Listen. So we know that the main component of vegetable oil is triglyceride, right? So you have to have the knowledge to grow this one, triglyceride. Do you already know, or you don't? Do you have to know? Triglyceride එක structure එක?
වෙනසක් තියෙන අපිට H එක C එක්ක දාලා.
කො?
C එකයි H එකයි දෙකම එක ළඟ දාලා. Normally
I expand කරලා ලියන එකද? Doesn't matter. එහෙම හරි මෙහෙම හරි you have to somehow know how to draw it. Right? Because it won't come to draw, but you have to know the structure. It will come, definitely will come. මේ වගේ structures අනිවාර්යයෙන් මතක තියෙන්න ඕනේ. by reacting this triglyceride with methanol, methyl ester of fatty acid and glycerol can be obtained. Now highlight this one. Now you are reacting this with what? Methanol, right? Reacting this with methanol. Right? You are reacting the triglyceride with the methanol, right? Right? Now this is the triglyceride and this is the methanol. You are reacting the methanol with triglyceride, right? And what happens? Produces a methyl ester of fatty acids. Highlight it. Now the product will be a methyl ester of fatty acid. Now what is this? Methyl ester of fatty acid is the biodiesel, right? Biodiesel. You can easily produce this at home, you know. But the only trouble is to find the methanol. Methanol is really expensive, you know. 1 liter would be somewhere 60,000 or more. For you, somewhere 60,000. Huh? And if you are buying it, like if you can't find any of the methanol, you can still put ethanol. Even ethanol would do. Chain එක පොඩ්ඩක් දිග වෙනවා එච්චරයි. 1 carbon වලින් වැඩි වෙනවා. That's all. Methanol ගන්න. Methanol is actually expensive. Methanol is poisonous. And it's hard to, you know, produce methanol. That's the thing. Now that's the issue of producing the biodiesel as well. Because to produce methanol, what you use is methane. You know, to produce methanol, they are using methane. They are reacting methane with water vapor. Reacting methane with water vapor produces methanol. So where do you get the methane from? From the crude oils. Yeah, from the crude oils. So to produce biodiesel, you have to have the. So without it, you can't do it, because you can't produce the massive amounts of methanol using any of the other resources other than the methane. So that's the issue. So this is a huge lie, isn't it? We're learning it. Anyways, right? So the biodiesel is produced. The biodiesel is methyl ester of fatty acids. Get it? Now these are anyways esters. Now this is also an ester. What is the ester bond? C double bond O R, right? Now the C double bond O R is there in esters, right? So that's the ester. And that ester is again converted to another type of ester, which is methyl ester of fatty acids, right? And the byproduct is what? Glycerol. So the byproduct of biodiesel will be glycerol, right? Right. This reaction results in a mixture of fatty acid, methyl ester, FAME, highlight it. Fatty acid, sorry, what did I say? Mixture of fatty acid, methyl esters. Fatty acid, methyl esters. I said fatty acid or something. That's wrong. Fatty acids, fatty acid methyl esters, right? FAME, fatty acid methyl esters. Are the biodiesel, right? Make a handful, fatty acid methyl esters, right? FAME. This mixture of fatty acid methyl ester is commonly called biodiesel, right? So this is biodiesel. It is known that the triglyceride in vegetable oils contain various fatty acids, right? So they have like different fatty acids because the R will be different, right? The R will be different, and apart from these are the triglycerides. Apart from the triglycerides, they have free fatty acids, right? Free fatty acids are also there, like RCOOH are also there, right? They are also there. So therefore, there are difference between the hydrocarbon chain R1, R2, and R3 in the triglyceride molecule. So this results in a mixture of methyl esters, right? So you're not getting like one exact molecule of biodiesel. It's a mixture of FAME. It's a mixture of FAME, not one exact molecule, right? So the main byproduct of biodiesel production is glycerol, right? Glycerol. That is the main byproduct. Methanol is produced from the methane gas. Now do you see this? Methanol is produced from the methane gas, right? So now this is the issue. Methanol is produced using the methane gas found in natural gas or the fossil fuels. I'll highlight that too as well. From the fossil fuels. Right. Now the energy has to be given here. Right. So CH4 plus H2O converts into carbon monoxide plus 2 of the hydrogens in the first step. Again in the second step, carbon monoxide again react with the water molecule to produce carbon dioxide plus another hydrogen molecule. So altogether it's producing how many molecules? How many hydrogen molecules? 3 plus 1, that is 4, right? And the byproduct will be carbon dioxide. So now another thing, what?
Carbon dioxide is produced in the bodies.
Yeah, it's another issue because the biodiesel is proposed to reduce the global warming because the fossil fuels increase the carbon dioxide emission. Now what happens here now? Producing the methanol, the byproduct will be carbon dioxide. Now isn't this increasing the carbon dioxide emission? It does, right? So, what happened? So it's not actually a replacement, isn't it? Right. So carbon monoxide gas plus 2 of the hydrogens under copper zinc produces CH3OH. Now there's a bit of issue. Give me a second. Where's my mobile? Couldn't find my mobile. Bro, can you bring my mobile? Not that. It's in the office room. Right. Make him admin on it here now. It's a different reaction though. Now the energy has to be released. Carbon monoxide reacting with the hydrogen produces what? At the end, CH3OH, right? So in this way, methanol is produced from natural gas, a non-renewable petroleum resource in earth, right? So therefore not all the raw materials for biodiesel produced using methane are 100% renewable raw materials, right? 100% are not, right? Not all the raw materials for biodiesel produced using methanol are 100% renewable raw materials. Now this is an issue. For this reason, scientists are focusing on the industrial production of methanol using microorganisms from carbohydrates, right? So if you produce the methanol using the microorganisms, right? Now that will be a different case because microorganisms won't need any of the crude oils, right, to produce the methanol, and there won't be any carbon emission as well. But the thing is, producing it at a rate that can supply the need will be really hard, right? Because the microorganisms can't produce it at a higher rate because අපි methane ගන්නවා වගේ crude oil වලින් microorganisms වලට ඕක හදන්න බෑ. So it's a bit of a not easy way, and culturing the microorganisms will take the laboratory level of a facility. So somewhat, right? The methanol produced in this way is biomethanol. Biomethanol. When biomethanol is produced, the biodiesel produced from it is 100% renewable raw material based on biodiesel, right? So that's true. So how do you make it? As they say, you use the wet or dry biomasses and reacting them with the bacteria, thermochemical. Sorry, here the wet biomass you are using it using the bacteria and producing the methane gas, or the dry biomass using thermochemical methods, right? Using sort of a thermochemical methods, you produce the methane gas, and producing methanol reacting with the triglyceride can produce biodiesel plus glycerin, right? That is the way. So make a flow chart. Now this will be important. Remember the flow charts can come. Right. Now what is the catalyst used here? Now even in this reaction it was said like a catalyst is used. Now what is the catalyst here? Now the catalyst will be sodium hydroxide. Right. The catalyst will be the sodium hydroxide. So NaOH is used as the catalyst. Right. NaOH is used as the catalyst for the trans esterification reaction. Now do you understand the meaning of this trans esterification reaction? What does it mean, like trans esterification? Trans esterification. What do you understand by that? Kali, what do you understand by trans? That's a different case. Now trans esterification, converting an ester to another different sort of a ester. That's what happens. Now see this one. So this is also a ester, right? This is a ester. Now this ester is replaced with another type of a ester, right? Because this part is a glycerol, so this is a alcohol, right? So this glycerol alcohol part is replaced by methanol alcohol. Do you understand that? The glycerol alcohol part is replaced by a methanol alcohol, right? So now this is a ester and is converted back into another ester, is called what? Trans esterification reaction, right? Ester to another ester. That's a trans esterification reaction. Get it? Trans esterification reaction that produces biodiesel. If free fatty acids are present in the vegetable oil, they react with NaOH to form soap. Now that's a trouble, right? In some of the fatty acids, apart from some of the oils, apart from the triglycerides, there are free fatty acids. What are the free fatty acids? What are the free fatty acids? Now what is triglyceride? What is it made of? What is the triglyceride and what is it made of? Fatty acid and glycerol, right? The glycerol molecule is there, and an R long chain R and a COOH molecule is there. Now three of those fatty acids reacting with a glycerol molecule produces a triglyceride that comes under the biomolecules. The part is less. The part is lipids. Lipids all අපි ඔක discuss කරනවා. Triglycerides. Sorry. Not the triglycerides. Triglycerides are produced of fatty acids and glycerol, right? Glycerol is reacting with three of the fatty acids to produce triglyceride, right? So these fatty acids are those R-chained COOH groups. So apart from the triglyceride, the oil itself, there are free fatty acids, right? So R-chained COOH groups are there, like the free ones. So what happens when the NaOH is reacting with them? They are producing soap, right? That we discussed, right? So they are producing soap, and so reaction that if the free fatty acids are present in the vegetable oil, they react with NaOH to form soap. So there should be less amount of free fatty acids in whatsoever the vegetable oil that you are using, right? Whatsoever the vegetable you are using, there should be a lesser number of free fatty acids, otherwise they will be end up forming the soap, right? And it is called the acid number. The amount of free fatty acids available in a vegetable is called as a acid number, right? Acid number, higher the acid number, higher the amount of fatty acids in a vegetable oil, right? So we have to measure the amount of free fatty acids in a vegetable oil, right? So this interferes with the catalytic action and makes it difficult to separate glycerol and biodiesel from each other, right? Right. So now this is what? What is this? That is a fatty acid. And reacting with NaOH, what is this? This one is? What is this? It's a soap, right? Fatty acids react with NaOH to produce a soap, right? Now this has to be avoided. The relatively high content of free acids in a vegetable oil makes them unsuitable for biodiesel, right? The amount of free fatty acids in a vegetable oil is measured by the acid value. Highlight it. Amount of free fatty acids in vegetable oil is measured by the acid value, right? Or the acid number. Either call it acid number or acid value. And these are important, right? These are important. The acid number indicates how many milligrams of KOH are required to neutralize 1 gram of free fatty acids in vegetable oil. Highlighted. This can come either to a essay or to a structured essay or even to a MCQ. Now what is the acid value? What is the acid value?
Fatty acid content free fatty acids.
Definition. What is the definition? Amount of KOH that takes to neutralize all the fatty acids in 1 gram of vegetable oil. Get it? Right. So higher the fatty acid, higher the acid number, higher the fatty acids, right? You have to remember. The free fatty acid content of vegetable oil should be less than 1 to 2% as in weight, right? Should be less than 1 to 2%, otherwise it will cause the producing soap and avoiding the action of catalyst or causing the catalyst action reduced. If there is a high amount of free fatty acid, it is difficult to produce biodiesel due to the formation of significant soap upon reaction with NaOH. We already know it. However, some experiments have shown that the acid number should be less than 1 milligram per gram of oil. 1 milligram per gram of oil. And the free fatty acid content should be less than 0.5. Now the weight by weight value, right? සමහර ඒවා 0.5 වලට වඩා අඩු වෙන්න ඕන කියලා කියනවා, right? Oils with relatively high free fatty acid content can be used for biodiesel production after reducing the free fatty acid content to less than 1%. හරි. අපි මේක less than 1% අඩු කරගත්තොත් those can be used to produce the biodiesel, right? So the acid number will be 2 milligram per gram, right? So the measure, like the maximum should be 1 to 2 weight by weight, right? Right. So the reaction of NaOH with free fatty acids produce water in addition to the soap. Water interferes with the reaction of free fatty acids to form esters. Now highlight that as well. Reaction of NaOH with free fatty acids produce water in addition. And water interferes with reaction. And water interferes with reaction of free fatty acid to form esters. Right. So many of the issues are there. Right. එතකොට අපිට කලින් තිබ්බ ඉෂුව එක මොකද්ද? fatty acids තියෙනවා. fatty acids තිබ්බොතින් catalytic reaction එක මොනවා වෙනවද? catalytic reaction මොකද? ඈ? What happens to the catalytic reaction? You guys are like completely drunk, out of your brains. How do you know why? Why? So that you are completely drunk. But bro, the catalyst itself is sodium hydroxide. So what happens when the free fatty acids react with the sodium hydroxide? The catalyst itself reduces. So the catalytic reaction has to reduce because it's reacting with something else.
Catalyst is getting used by the
To produce soap. So the catalyst is removed, producing soap because the catalyst is reacted with the fatty acids, right? Yeah. Soap is a no, like soap can't be produced. Oh, ඒක අර ඒකින්දනේ මේක වර 1 to 2% වලට අඩු කරගන්න කිය.
නෑ ඒක තිබ්බොත්
වැඩියෙන් තිබ්බොත් බෑ. ඒක මේ බයෝඩීසල් එකේ soap එක අයින් කරන්න වෙනම effort එකක් දාන්න.
කියන්නේ ඒක වැඩි වුණොත් soap එක හැදෙන්න පුළුවන්.
වැඩි වුණොත් soap හැදෙනවා. ඒ හින්දා සාමාන්‍යයෙන් 1 to 2% තියෙන oils ගන්නෙ නෑ. Right? You didn't understand, I don't think, like me. Did you even at least understood 50% of this what I discussed? Soap හැදෙනවා. Oh, that is one issue. Yes, and the other issue is, apart from the catalyst being used, what else? A water molecule is produced, and water molecule is interfering with the the transesterification reaction is disturbed with the water molecules that is produced. Yes, understood somewhat? Yes, something okay. Right. So the catalyst NaOH is dissolved in methanol and reacted with the vegetable oil. Therefore, it is a homogeneous catalytic process. Now highlight that one. Catalyst NaOH has to be dissolved in methanol first, right, before adding it to the oil, because you can't dissolve NaOH in oil, can you? Can you dissolve NaOH in oil? Why not? The polar non-polar at least, right? The polar non-polarity is there because the NaOH is polar and the oil is completely non-polar, so they don't dissolve each other. That's one thing. And react with vegetable oil. Therefore, it is a homogeneous catalytic process, right? So it's a homogeneous catalytic process, and yes, what do you call that? Yeah.
Same molecules.
Like there are two types of catalysts. What are the two types of catalysts? Depending on the nature of the no. Homogeneous catalyst and heterogeneous catalyst. Now, what are the homogeneous catalysts?
Same type of molecules than the catalyst.
What do you mean?
හැමතැනම same එකම ගානට මේ
No. We'll somewhat write something, but no. won't gonna work.
වචනම එකම විදියට
එකම catalyst එකේ heterogeneous එකේ දෙක කියන්නේ
කොයි තැනක ගත්තත් එකම විදිහේ මේකත්
Bro, no, you have to study more. You have to, bro, what the hell, no. No. Homogeneous is when the reactants and the catalyst are at the same state of matter, like the liquid, or the solid, or the gas. Likewise, it becomes heterogeneous when the reactants and the catalysts are in two different state of matter. Yeah, homogeneous, heterogeneous. Study, right?
ඔය homogeneous කියන්නේ අර මේ
Mixtures, bro. Those are mixtures. No, homogeneous catalysts and the mixtures are different things. No, these are not mixtures. Those are catalysts, right? That's why you should study more. You think you have time? No, you don't have time, ne? Right. So in addition, me make a note bro. Put a note there. When you find something that you couldn't remember, me put a note. It's a good thing. And do it fast. We don't have much time. Okay. Fine. Where did we discuss these homogeneous and heterogeneous catalysts? Kinetics, yes. Right? Okay, in addition, oxides such as magnesium oxide, zinc oxide, or tin oxide, which are insoluble in methanol, can also be used as catalysts. If you use these catalysts, magnesium oxide, zinc oxide, tin oxide, they will be which type of a catalyst? Are these liquids?
gases.
No, bro, these are gases, these are solids.
Oxide and gases are the react with each other.
Oh. So these are solids. So what are these type? Heterogeneous catalysts, right? Which are insoluble in methanol, can also be used as a catalyst. Since these catalysts are insoluble and remain as solid particle, they catalyze the biodiesel production reaction as a what? Heterogeneous catalyst. Right. So if 100% biodiesel is not blended with petroleum diesel, if 100% biodiesel is not blended with petroleum diesel, the biodiesel is designated as B100. B100 means 100% biodiesel, right? 100% biodiesel. When 20% biodiesel is blended with 80% petroleum diesel by mass, it is designated by B20, which means biodiesel 20. So 20% of the biodiesel and 80% of petroleum. So the 20 represent the percentage of biodiesel. So these questions can be asked now. What is B20? What is B2? B5? Can be asked, right? So what is B20? 20% biodiesel, and the rest of it is petroleum, right? So B2, B5 and B20 are often used commercially, right? Biodiesel production process. There are several basic steps involved in the biodiesel production. First one is removing free fatty acids and other impurities from the oil. Now first thing is removing free fatty acid. Why do we have to remove the free fatty acids? Now how much should there be in like weight wise, weight percentage, how much should be there? 1 to 2% should be there. So like if it goes below the 1%, sorry, it goes above the 1% or 2%, so it's not recommended as an oil for the production of biodiesel, right? Right. So trans-esterification step, here triglycerides triglycerides and methanol are mixed. Methanol and triglycerides or biodiesel do not mix but remains as two separate liquid phases, right? Now the methanol and triglycerides are reacting but they don't mix because they are two of the polar and non-polar components. So they make two immiscible layers, the above layer and the top layer and the bottom layer, right? And in the intersurface, what happens? In the interface, the biodiesel is produced. Do you get it? Like there's a methanol layer and there's a oil layer, and the interface, what happens? The biodiesel is produced. Get it? Depending on the density, it will go somewhere. Usually it goes up. So what do? Would you keep it like two separate immiscible phases? Then what do? You mix it. Barrel like betting Holland thing. Right? So you mix it that all the either the methanol particles go through the oil phase or the oil particles go through the methanol phase. That has to happen so that the reaction occurs, right? Methanol and triglycerides are biodiesel do not mix but remain as two separate liquid phases. More methanol is added for the reaction. Now, if more methanol is added, would the methanol go inside the oil phase or the oil would go the methanol phase? What do you think? Oil goes inside the methanol phase because more of the methanol is there. So we call that phase which has more molecules as the continuous phase because it's continuing, right? It is a continuous phase, right? So let's read this one. Therefore, more triglycerides become biodiesel. More methanol is mixed with glycerol. The denser glycerol is the lower layer. More triglyceride become biodiesel, more methanol is mixed with glycerol because the glycerol are also polar components, so they dissolve in methanol, right? The denser glycerol is the lower layer, it goes down. The less dense biodiesel is separated as the upper layer on top of the glycerol. Since the boiling point of methanol is 68 degrees of Celsius, the temperature at which this reaction is carried out must be below 68, highlight it. Its reaction is carried out must be below 68 degrees of Celsius. Right. Now highlight this one as well. More methanol is added. So more methanol is added means this becomes the continuous phase. More methanol means continuous phase. Right. Now this becomes a continuous phase. Thank you. Like the drug dealers. Right. This is a continuous phase and the oil becomes a dispersed phase. Right. Therefore, more triglyceride become oil becomes a dispersed phase. It's dispersing, isn't it? Right. Triglycerides become the dispersed phase. Dispersed phase. It becomes a dispersed phase, right? right? So the reaction should occur at below 68 degrees of Celsius. Why? The boiling point of methanol is 68. If you increase the temperature, the methanol will evaporate, right? It will escape, and it's really expensive. If the methanol escapes, it will cost much more, right? And refinement of impure diesel. Impure biodiesel contains methanol, the catalyst, and glycerol, right? By removing these impurities, refined biodiesel is obtained, right? So now the impure biodiesel contains what? Unreacted methanol. Bro, carried must be it, right? Now impure biodiesel contains unreacted methanol. What is the catalyst here? No, catalyst is NaOH. Catalyst and the glycerol. Glycerol is the byproduct. The catalyst is the NaOH, right? Put a comma here. It's comma. Nice comma. Put a comma. Right. Right. Glycerol refining. The glycerol contains methanol catalyst. Glycerol contains methanol catalyst and a small amount of biodiesel. The first step is to remove the impurities and increase the purity of glycerol. Now the glycerol contains a small amount of methanol and biodiesel in it, right? The glycerol contains a small amount of methanol and biodiesel in it. You have to remove it to purify the glycerol, and glycerol is also one of the expensive products, right? Cosmetics sold him gun. So biodiesel is heated to remove methanol. Then the methanol evaporates. The vapor is condensed to recover methanol, right? So you have to heat it up to escape the methanol, and you have to dense it again and recover all the methanol escape, because it's expensive. You can mass pele and then the expensive. You can recover karanna ona. The catalyst is washed with diluted sulfuric, then further washed with water. Why do you wash the catalyst with diluted H2SO4? Because the catalyst is NaOH, so it will react and neutralize, right? So when further wash with water and if you want to clean it further, what do you clean the biodiesel with? If you want to clean the biodiesel further, now we removed the catalyst with H2SO4. Apart from that, what is left in the biodiesel? Glycerol is left, and could be a little bit of methanol, but we said that we will heat it up to evaporate the methanol. So that way you, let's say like the complete methanol is escaped and the catalyst is reacted with sulfuric, it's gone. So what is left now? Glycerol is left. So how do you take off the glycerol? Because the water doesn't react with the biodiesel, so they will separate in two layers. And the glycerol that contains inside the biodiesel which will wash away with the water. That's what they really do. Right? වතුර පාරක් කල්ලන උඩි. ඇල්ලුවාම පස්සේ glycerol ටික හොදගෙන පල්ලෙහා ලේයර් එකට යනවා වතුර ටික. උඩ biodiesel ටික ඉතුරු වෙනවා. හරි. Right. Then further wash with water. The remaining methanol and glycerol dissolve in water, which leads to the biodiesel being refined. For this, water is bubbled through the biodiesel. Then the glycerol in the biodiesel dissolve in water. Finally, the wet biodiesel is dried to remove the water in the biodiesel. ඊට පස්සේ අන්තිමට wet biodiesel එක පොඩ්ඩක් වේලෙන්න දෙනවා. අර water එකට escape වෙන්න dry කරගන්න. හරි. Now production of that's it. Production of phosphate fertilization. Now that's it. Right. අපි ඊට පස්සේ මෙන්න මේකත් highlight කරමු. Water is bubbled through the biodiesel, then the glycerol in the biodiesel dissolves in water. Understood it so far? Manageable? ප්‍රශ්නේ නෝ. Like now better if you can continue doing. Now did you all do the MCQs, 50 MCQ questions? Correct. Now continue doing it. 50 MCQs, past paper. Do it at least like 2 MCQ papers once a week at least, minimum. You have to do it. Nee, check කරගන්න ඕන. Did you do it? නේ මේක කරන්න වෙනම අරක වෙනම කන්නේ කියන්නේ අරක කරන්නේ ටයිම් මැනේජ්මන්ට් ඒව හදාගන්න. කියන්නේ ක්ලාසිෆිකේෂන් එක කරාන් පස්සේ ලෙසන් එක ගොඩ යනවා. ෆුල් පේපර් එක කරාන් පස්සේ තමයි එක්සෑම් එක ගොඩ යන්නේ. ඒ කියන්නේ පේපර් එකට ටයිම් මැනේජ් කරගන්න ඕන විදිය ටික තේරෙන්න ඉපේ. ඊට පස්සේ කීයක් වදිනවද කියන එක බලා ගන්න ඕන. මොනවද ලෙසන්ස් බැරි? ඒව ටික අපි හොයාගන්න ඉපේ. ඒක හොයාගන්න ෆුල් ඒව ගහන්න ඕන. ෆුල් ඒව ගහන්න ගියවේ නේද? සේෆ්ටි වල බල මොනවද කරේ? IT වලට කරා. යහන් තම්බේ කාලි කරා 15 16 1980 now. Okay, you're starting from the middle. Okay, you did something I know.
17 months I gave.
Yeah, so you have to continue doing it, otherwise you don't know. එහෙම නිකන් ඔහේ මොනා හරි කර කර ඉඳ එක්සෑම් එකට යන්න එපා. හොඳේ, you have to get ready for that, get used to it, like get used for the paper as well. Apart from the 50 MCQs, I like me මං කිව්වා ඔක ගහන්න කිව්වේ එන කලින් හොඳේ. දැන් මං හිතුවා මේ එනකොට දැන් 23වත් ඇති කියලා දැන්. මේ වෙද්දි 50 වගේ ගහලා. අඩු ගන්න දැන් වෙනකොට අඩු ගානේ 50 මේ 23 වෙනකන්වත් 50 MCQ ටික ගහලා තියෙනවා. Apart from that, try to continue. Now you did the stat part. We did many of the essays, right? The other part is which one? This one. This coordinate geometry and the area volume question that comes under the first part of the essay, right? So 2 of the questions are from mathematics. Continue all that questions segment by segment, like the first part, 2 of those questions for 2015 to 2024 කරගෙන යන්න. ඊට second part physics ඒව ටික essay දෙකක් තියෙනවනේ. ඒ දෙකම කරගෙන යන්න. ඊට පස්සේ third part chemistry දෙකක් තියෙනවනේ essay. ඒ දෙක වෙන වෙනම කරන් යන්න. දැන් මේවා ඉවරනකොට කරන්න පුළුවන්. මේකත් ඉවරනකොට කරන්න පුළුවන් C part එකත් chemistry part එක. කරගෙන යන්න, you will find a pattern. What kind of questions will come to those separate parts. හරිද? එතකොට first එකේ මොනවද එන්නේ කියන එක ගැන identify කරගන්න පුළුවන්. එතකොට ready වෙන්න පුළුවන්. stat එකට ලියනවද? coordinate geometry කියලා නේ. පොල් කැලලද කේජු කැලලද කියලා select කරගන්න පුළුවන්. හරි. කෝකද කියලා දැම්ම select කරගන්න පුළුවන්. ආට stat එක නම් stat එක set වෙනවා. coordinate නම් coordinate එක set වෙනවා. බලා ගන්න පුළුවන්. ඊට පස්සේ physics part එකත් කරන්න. physics part එක කරනකොට තේරෙනවා මොනවාද එන ප්‍රශ්න, මොනවාද අහන ප්‍රශ්න. හරි. ඊට පස්සේ අනිත් එක තමයි ප්‍රශ්න ටික ලියලා මාකින් එක බලන්න. හරි. මාකින් එක බලන්න. මාකින් එක බලලා බලන්න ලකුණු කීයක් තියෙනවද කියලා. ඊට පස්සේ බලන්න ඔයාට ඔය එනවනේ අමාරු ප්‍රශ්න. ඒ අමාරු ප්‍රශ්න වලට maximum essays වල හරිද? ලකුණු 25යි යන්නේ. maximum. අර එන හද්ද අමාරු ඒවා තියෙනවනේ මට උඩ මේක නම් කරන්න බෑ කියලා හිතෙන. maximum ලකුණු 25යි අඩුවේ. 125 you can mark score for sure. හරි. maximum ලකුණු 25ක් අඩුවේ. එතකොට ඔයා calculation කරලා බලන්න. මට මේ essay එකකට මෙච්චර marks ගානේ essays 4ක් ලියලා essay part එක මට මෙච්චරක් score කරගන්න පුළුවන්. ඒ ප්‍රශ්න ලියලා දන්නවනේ දැන් මට මෙන්න මේ වගේ level එකකට ලියා ගන්න පුළුවන් කියලා. එතකොට බලන්න ඔයාලට කොච්චර marks තියෙනවද කියලා. ඒකේ. ඊට පස්සේ structured එකට ඕනේ කොච්චරද MCQ එක ගහලා දාන්න MCQ කීයද කියලා ඔයාගේ ග්‍රේඩ් එක ගැන සෝෆා රෆ් අයිඩියා එකක් ඔයාලට ගන්න පුළුවන්. ඊට පස්සේ ඒක ඉම්ප්‍රූව් කරගන්න තියෙන්නේ. හරි. ඒක ඇන්තික බය යනවා. එකක්. මොකද අර SS කරනකොට ඔය අමාරු එක අහුවෙනව නේද? මුළු ගානම කිලවනවා. ඒ කියන්නේ ඒ අමාරු එක තියෙන්නේ මැද. ආපහු අන්තිමට දිනන ලේසි එකක්. අර අමාරු එක කෙලෙවිච්ච ගමන් අන්තිම ලේසි එකත් මොකද වෙන්නේ? ඒක බැරි වෙනවා. එයාටගේ අමාරුයි පැනික් එකට ඒක බැරි වෙනවා. ඊට පස්සේ ඒක ඊළඟ AC එකටත් එලෙසම යනවා. හරිද? ඒකින්ද ඔය එක්ස්පීරියන්ස් කරන්න දැන්. ඒව දැන් එක්ස්පීරියන්ස් කරන්න නැත්නම් එක්ස්පීරියන්ස් කරන්න කොහෙද? එක්සෑම් එකේ. එක්සෑම් එකේදී එක්ස්පීරියන්ස් කරන් පස්සේ මොකද වෙන්නේ? සෙකන්ඩ් සයිඩ් එකේ තමයි හරියට එක්සෑම් ලියන්නේ නේද? that will definitely happen. හරි. අනිවාර්යෙන් ඒක එක්සෑම් එකට කලින් එක්ස්පීරියන්ස් කරගෙන නැත්නම් එක්ස්පීරියන්ස් කරන්නේ එක්සෑම් එකේදී. ඒතර පැනික් වෙනවා. එකක ෆී එක අනිත් එකට යනවා. ඊට පස්සේ එක ඒව ටික නැති වෙනවා. ඒ හින්දා ඔයාට මාක් කරන්න පුළුවන් කොච්චරද කියන එක ගැන හොඳ අයිඩියා එකක් ගන්න. සෙග්මන්ට් කරලා කරන්න. කරන් පස්සේ ඔයාට තේරෙයි මේ මේකට මෙච්චර ඕනේ නැහැ නේ කියලා. මෙච්චර මැරෙන්න ඕනේ නැහැ නේ කියලා තේරෙනවා. හරි. ඒක කරලා බලුවම පස්සේ තමයි තේරෙන්නේ. ඒක කරලා බලන්නේ ඒකින්ද ප්‍රැක්ටිස් කරනකොට තේරෙයි. මාකින් එකත් එක්ක බල බල ලකුණු දාලා ටයිම් කර කර කරන්න. හරි. මේ ටිකේ තමයි ඒක කරන්න ඕන. ආපහු මේක නිකන් මාසයක් විතර තියලා එහෙම කරන්න බෑ. ඒතර දැන් යනකොට හරිනම් 23 වෙනකන්වත් 50 MCQs ගහලා තිබ්බනම් MCQ එක දන්නවා දැන් පැටර්න් එකක් දන්නවා. ඔයාලට මාක්ස් කොච්චරද කියලා දන්නවා. වැඩි කරගන්න මොනවද කරන්න ඕන කියලා දන්නවා. seven done it. හරි. අර don't be me like the stone people. ඔහේ ඉන්න එපා නේ. Like you smoke something. Right? So have a progress, do something that shows a growth. Nee? Otherwise, you will end up doing a lot of work but having a small grade. That will happen for sure. Right? Don't do a lot of works and end up having a low grade without experience the you know the necessary things. Again, the necessary things ටික පොඩ්ඩක් හරියට ටාගට් කර කර කරන්න. නැත්නම් it will be troublesome. right? try කරන්න ඒ කියන්නේ දැන් 50 MCQs ටික ගහන්න දැන්. එතකොට පැටර්න් එක අහු වෙනවා. SS ටික ඩබල් කර කර ඒවා කරන්න පාර්ට්ස් වෙන වෙනම කරන්න. ඔය ෆස්ට් එක දැන් කරගෙන යන්න පුළුවන්. ඊට පස්සේ ඒ ටික කරන් යනකොට අහු වෙනවා. දැන් මේ අවුරුදු 10 ඇතුළත එන්න පුළුවන් වර්ග ගොඩක් ඒවා ඇවිල්ලා තින්නේ. ඒ හින්දා බය වෙන්න එපා. ඒ කරාන් පස්සේ ඔය ඇතුළේ එකක් තමයි. උතනින් පිට එන්නේ. dead sure. I am telling. කරලා බලන්න. හරි. උතනින් එහා එකක් එන්නේ. පැටර්න් එක අල්ලගන්න තමයි ඕන. හොඳයි. බ්‍රේන් එකට දාගන්න ඕන පැටර්න්. තොරව බලන්න. කරගන්න පුළුවන්. හරි. Right. Come to the production of phosphate fertilizers. Phosphate fertilizers are produced to provide phosphorus compounds necessary for plant growth. That we all know, right? Phosphate is necessary for the plant growth. And which and like there's a huge reservoir of phosphate here in Sri Lanka. Where? කොයිද phosphate reservoir එකක් තියෙන්නේ? Epal, didn't you know? Epal, yeah. 600 million or billion tons were there. You know, if you refine it here, you can pay all the debts at once. That much of a phosphate amount is here. But we don't have the technology and the raw materials to produce the produce and to refine the phosphate fertilizers. So because of that, we have to sell the raw materials to the other countries, so they produce the phosphate fertilizers and they are selling it back to us and earning more than us using our resources. That happens, right? So do something about it after the degree finishes. Phosphate fertilizer, now we discuss it. Raw material for this process is mineral apatite, right? There are three types of apatite depending on the chemical composition. So one is chloroapatite, which has chlorine at the end. The other one is fluoroapatite, which has fluorine at the end. And the other one is hydroxyapatite, which has OH at the end. Now these you have to remember, right? So what are the three types of apatites depending on the chemical composition? Fluoro and hydroxy. Right? Chloroapatite, fluoroapatite and hydroxyapatite. These can come. This will definitely come somewhere. The water solubility of this apatite is very low. For example, the water solubility of fluoroapatite is low as 0.4% by mass. Right, the water solubility card. Low solubility of this apatite is low. හරි ගොඩාක් අඩි. ඒකින්ද මෙයාගේ solubility එක වැඩි කරගන්න මෙයාව react කරන්න වෙනවා මොකක් හරි chemical එක්ක. Usually they are using sulfuric, phosphoric and nitric kind of acids. acid එකක් එක තමයි react කරන්නේ. එහෙම react කළා මේගොල්ලෝ හදනවා එක එක phosphate types. TSP, SSP, single superphosphate, triple superphosphate, likewise acids එක react කළා මේගොල්ලෝ හදනවා soluble types of phosphate, right? So therefore apatite fertilizer is not suitable for use as a fertilizer for short term crop cultivation. Short term crop cultivation කියන්නේ ඉක්මනට හැදෙනවා 3 months වගේ යන්නේ. දාන්න බෑ ඇයි? මෙයා break down වෙලා පස් වලට phosphate දෙන්න යනවා සෑහෙන කාලයක්. ඇයි? They don't dissolve in water. නේ. ඒ හින්දා apatite can be ground and acidified. හරි. Ground and acidified. Now this is important. Acidify කරන්න to increase its water solubility. It should be acidified. Adding sulfuric acid produces phosphate fertilizer called single superphosphate. Sulfuric වලින් හදන මොනවාද? Single superphosphate, which in short we call SSP. It's one of the police ranks, isn't it? SSP. What is it? SSP is also there. Single superphosphate. Tell them if you ask. Single superphosphate, SSP. SSP is also there. This is one of my uncles. Was one of the SSP. I think he's on like 2 or 3rd rank. I don't know him. Like adding phosphoric acid produces a phosphate fertilizer called triple superphosphate. Adding phosphoric acid produces triple superphosphate. What is it? TSP. The phosphorus content of fertilizer is expressed as P2O5. That is also important. Potassium pentoxide. Something vibrating. That's that one. Who's saying? The vibrator is vibrating. Now the phone is vibrating. Right? So the phosphate is contained as P2O5. Right? The phosphorus content of SSP obtained by adding sulfuric acid is how much? 16 to 21%. 16 to 21% වෙනකම් sulfuric acid කරලා අපිට phosphorus level එක වැඩි කරගන්න පුළුවන්. The phosphorus content of TSP, triple superphosphate, adding phosphoric acid is 43 to 48%. වෙනකම් phosphate level එක වැඩි කරගන්න පුළුවන්. Right? The apatite deposit in Eppawala, Sri Lanka has an estimate phosphate content of over 60 million tons. Oh, that's a lot, right? 60 million tons are there. The phosphorus content is 30% as P2O5. ඒකේ 30% තමයි තියෙන්නේ P2O5. නේ. The halogen F and chlorine are also present in apatite. Now the halogens are the 17 group molecules which are chlorine, bromine, iodine. නේ. ඒ දෙකෙන් මෙන්න මේ දෙන්න. Who? Fluorine and chlorine තමයි ඒකේ වැඩිපුරම තියෙන්නේ. Are also present in apatite. Of the two halogens, right? Because like there were two of the halogenic phosphates ni මොනවාද apatites ni fluoroapatite and chloroapatite. ඒ දෙකෙන් මේ F එකයි Cl එකයි තමයි වැඩිපුර තියෙන්නේ ඔය Eppawala එකේ. F is the most abundant in Eppawala apatite deposit. Of these two halogens, Cl is most abundant in Riddigama apatite. Riddigama apatite එකේ තියෙනවා මොනවාද? chlorine. Eppawala එකේ වැඩිපුර තියෙන්නේ chlorine. අහන්න පුළුවන් කියන්න බෑ. Even if a country has phosphate deposit, if it does not produce H3PO4, which is phosphoric or sulfuric acid locally, then those acids have to be exported. In It is important, yes. Bro, someone is calling. Should we answer it? Ah. Which? Okay. Okay, understood. Right. Right. In particular, the high cost of sulfuric makes the production of superphosphate an economically limiting factor in Sri Lanka. Like we don't produce any of the sulfuric, right? So if you are planning to produce sulfuric, produce it somewhere close to Epavalo Ridigal. So it will benefit you. කොහොමද විකුණ ගන්න පුළුවන් එහෙට. අපිට phosphate හදලා ගේමක් ගන්න පුළුවන්. So there's little tendency to produce SSPO, TSP since sulfuric or A3PO is not produced locally. In such cases, fertilizers are produced using sodium carbonate, NaOH and serpentine. මෙන්න මේ ටිකෙන් තමයි ලංකාවේ හදන්නේ හොඳ. අපිට අරව නැති හින්දා අපි මෙන්න චූටි චූටිව පාවිච්චි කරලා ගේමක් ගන්නවා. Sodium carbonate, sodium hydroxide and serpentine, which is magnesium silicate, MgSiO4, is used to produce the fertilizers, right? Right. So reaction of apatite with sulfuric acid, hydrochloric acid and nitric acid are given below. Now these apatites can be reacted with these acids as well and to produce no. But you should know that they can be reacted with these acids and can be produced the more soluble phosphate fertilizers, right? The presence of calcium ions in these fertilizer creates a hygroscopic nature, which is what is hygroscopic nature? Hygroscopic, what does it mean? It attracts the water molecules, right? It attracts the water molecules. The hygroscopic nature is there. This causes the fertilizer to become wet, right? Like the watery wet. To prevent this, ammonium salt are added, right? So the ammonium salt is added to prevent it, so that it won't be wet anymore. When mixed with sodium carbonate salt and heated to 900 degrees of Celsius about 2 hours, the water soluble compound CaNaPO4 will be produced. Now this is produced here, right? Right. So make a highlight කරගන්න. When mix. Now make a කොහොමද highlight කරගන්න ඕන? Calcium ions තියෙන ඉඳ මොකද වෙන්නේ? Hygroscopic nature is there. And hygroscopic nature එක නැත්නම් wet ගතිය නැති කරගන්න මොනවද දාන්න ඕන? What do you put to get rid of the wetness? Put ammonium salts. Remember these things. Right. Right. So when mixed with sodium carbonate, salt and heated to 90 degrees of Celsius for about 2 hours, මේකත් ඕන. Sodium carbonate එක heated 900 degrees of Celsius about 2 hours. Water soluble calcium sodium phosphate is a result. This is produced in Sri Lanka, right? Now this is the reaction. So for phosphate fertilizer obtained by heating serpentine, which is also produced in Sri Lanka, at 1200 degrees of Celsius contains magnesium 2 plus ions, which is an added advantage, right? Produces water soluble magnesium phosphate. This one, it is also water soluble, right? The solubility of apatite is also increased somewhat by reacting it with organic acid present in the peat as well, right? So that can be also done, right? The last part, production of what? Caustic soda, right? So that's all about the phosphates. Now it's about the caustic soda to produce, right? So you all understood so far what we discussed? Fine, right? Okay. No, I don't hear the sound. No. Now give one of your friends' number as well. Give Ryan's number. Eh? No, I'm not saying now. If she gets panic, she can call and ask me because you are all going to same classes. By anyone. I'm not sure if them. Yeah, okay. දැන් කෑල්ලගේ නම්බර් එක දුන්නා ඉවරයි ප්‍රශ්නයක් නැහැ නේද? ඒකට කෝල් කළා නම් ඔයා ඇත් එක දින්නේ කියලා. නැත්තම් ප්‍රශ්නයක් නැහැ. Right, production of caustic soda, sodium hydroxide. The compound known as caustic soda is chemically NaOH, the sodium hydroxide. It is a basic compound made up of two type of ions, which is sodium plus ion and OH minus ion. Put the plus and minus ion, sodium plus, OH minus. That dissolve in water. Right, that dissolve in water. The chemical basis for the production of caustic soda is electrolysis of aqueous NaCl. This is produced using the electrolysis of what? Electrolysis of aqueous NaCl. Right? We are electrolyzing the aqueous NaCl, which reacts with aqueous NaOH to produce Cl2 and H2O gases. Now these are the byproducts. Cl2 and H2 gases are the byproducts. It's a by. Those two are by, right? Cl2 and H2 gases. Right. So this is the complete reaction. H2O and NaCl reacts to produce NaOH, Cl2 and H2. Right. This will be the final. Right. It should be understood that water is also reactant according to the chemical equation above. Right. Also here water is a medium to dissolve NaCl and the medium in which the reaction takes place. Right. Understandable. Although the chemical formula for water is written as H2O, a very small amount of this water molecules dissociate into H plus ions and OH minus. This is important. A very small, what the hell, bro? Why do I always mix up the pen and the highlight? Very small amount of this water dissociates, like breaks down into H plus ions and OH minus ions, which is this reaction. Very small amount of it happens, right? Not the whole thing. Very tiny, small amount happens, right? So you have to remember this, breakdown of water molecules. Reaction you have to remember. And even this reaction, if it is possible to remember, it's a good thing. Right. When NaCl dissolved in water, aqueous sodium and aqueous chlorine ions are the major ions, right? Depending on concentration, right? Because the NaCl are the major ions, because the water molecule dissociates to produce only a small amount of H plus and OH minus only. So the majors are the sodium and chlorine ions, right? The H plus and OH minus ions are also present, resulting from weak dissociation in water, right? When an electric potential difference is applied to this aqueous medium using electrodes, positive ions, sodium plus and H plus ions, migrate towards a negatively charged electrode, and negative ions, chlorine and OH minus, migrate towards a positively charged electrode. This is due to the electrostatic force of affrication between opposite charges, right? So what happens if you like give two of the positive and negative electrodes or the electric charges to the solution? The positive ions runs to the negative electrode, and the negative electrons, the negative ions runs to the positive electrode. That happens, right? That is electrostatic attraction, right? So this is happen, right? What happens? OH minus and Cl minus are running to the positive electrode, right? And the positive electrode is called what? Anode. And the negative electrode is called cathode. Now in Sinhala, there's an easy way of reminding the the which electrode is positive and the which electrode is negative. How? They say anode positive or negative? Positive. Cathode negative. Anode dana, cathode red. Easy to remember if you forget anyway. Anode dana. Anode dana, cathode red. Simple. Understandable, right? So anode positive, the cathode negative. If you ever forget it, right? So the minuses, the negative ions, listen, the negative ions runs to the positive, which is the anode, right? Right. Among these negative ions that comes near the positively charged electrode, the ion that can easily transfer is transfer its negative charge to the positive charge electrode. The reason for this negative charge is that there are more electrons than the protons. Now though the two of these ions run to the electrode, only one gets a chance. That happens, right? Because there's only like the positive electrode is there, like two of the ions are running towards the OH and CH. Oh, let's say the Kamala and Vimala are running to the anode. What happens? Only one gets the chance to what? Yeah. To give the electron, right? To give the electron. Now they are running to give the electron. That's what they do. Like the positive electrode is there to gain the electrons, and the electrons are always there to give the electron. That is oxidation and reduction reaction, right? So what here happens is the negatives are running to give their electrons to them. So whatsoever the electron means, they are trying to give it, and the anode only takes from one. Could be Kamala or Vimala. In this case, this could be OH minus or Cl minus. So which do you think the gets the priority? OH minus? Reactivity series එකෙන් තමයි ගන්න. We don't have to mention those things for the exams. We don't need it. No. OH minus remains. නේ එයා තනි වෙනවා. Cl minus දෙනවා. හරි. Cl minus තමයි chance එක දෙන්නේ හම්බෙන්නේ දෙන්න. ඒතර එයා දෙනවා. So OH minus remains. Because of that, OH minus is accumulated here. Is it a good thing or a bad thing? Good for sodium, because here happens the same thing. In the cathode minus, what happens? The positive ions runs toward it. Though the both runs toward it, only one gets the priority. Who gets the priority? The hydrogen gets the priority. Who is remained? Now the sodium is accumulating. So good for sodium, because sodium is accumulating from this side, and the other side the OH is accumulating. What happens to these two guys? They're bonding and produces what? Sodium hydroxide, which is caustic soda. And the chlorine here becomes, chlorine ion becomes a gas, hydrogen ion becomes the gas here, right? Two of them are escaping as chlorine gas and the hydrogen gas, right? So only one gets the priority. Therefore, when a negative charge is given, the negatively ion donates electrons to the positively charged electrode, right? Now the negatively charged ions are going and donating the negatively charged electron, right? Positively charged electrode changes its chemical environment by gaining electrons. Positive charge ions are gaining the electrons. So that is what? Oxidation or reduction? Gaining electrons? Bro, gaining is reduction. Yeah, that's deep, but that's true. Gaining is reduction, and giving is oxidation, right? I just remember gaining is reduction, right? Gaining is reduction always. It happens. More you gain, less you have. Even this Kung Fu Panda's master, who's there? Not the Shifu, the other one? Ugui. Ugui says it. What? More you gain, less you have. That's true, that's deep, but can be applied for the electrolysis as well. So gaining here is reduction, right? So the here, the positive electrode is gaining over. What happens there? The electrons are giving, right? The electrons are giving. So electrons are giving means oxidation. Here the electrons are gained. That is reduction. So the anode oxidation occurs. The cathode reduction occurs, right? Right. The reduction of the negatively charged state by donating electron is considered oxidation, right? The shall be donating electrons. Shall we take it this way? Donating. Oh, what happens? Now, donating electrons is considered oxidation, right? The electrode that is oxidized is called the anode. That is also important. The electrode that is oxidized is called anode. So where the oxidation occurs, it is anode, right? Therefore, in the electrolysis process, the positively charged electrode is the anode, right? So the positively charged one is anode, right? In an aqueous NaCl solution, the oxidation of the monoatomic negative ion, which is the Cl minus, is dominant compared to the diatomic negative ion OH minus. Now, between the Cl minus and the OH minus, competition, who wins? The Cl minus wins. The OH minus remains single and finds another ion afterwards and becomes sodium hydroxide. So that is caustic soda production, right? So doesn't it sound like someone is producing, like someone is doing that for us as well? Like we are the ions. You don't get it? Like we are the ions. Can happen. Alright. Yes. So in an aqueous NaCl solution, the oxidation of the monoatomic negative ion Cl minus is dominant compared to the diatomic negative ion OH minus. Now the Cl minus is dominant. Put the minus here as well. Cl minus is dominant compared to the OH minus ion. Compared to the OH minus. That moves toward the anode, and Cl2 gas is released from around that electrode because two Cl ions are oxidized to form a Cl2 molecule. This oxidation process can be described as follows: two Cl minuses converted into Cl2 plus 2E. Now this happens in the where? Anode, and this process is a oxidation. Right? What else? Among the positive ions that comes near the negatively charged electrode, the positive ion that can easily acquire negative charge acquires a negative charge from the electrode. Due to this, the positively charged decrease and its chemical environment changes. Here too, an electron migrates from the surface of the negatively charged electrode to the positively charged ion. Reduction is the process of reducing positive charge by gaining electrons, right? That we already know. Reduction. What are you laughing at? What's wrong? We have more time. What? You told who? Are you waiting to go home? Me ළඟනේ මේ අලපුවත් පයින් යතේ කොහෙද දෙහිවල සත්වත් සත්වත්තන් දැන් වහලා Reduction is the process of reducing the positive charge by gaining electrons, right? The electrode that undergoes reduction is cathode, right? And that is the cathode. In electrolysis, the negatively charged electrode is called the cathode, right? Negatively charged electrode is cathode, right? In the electrolysis of an aqueous NaCl solution, the H plus ion is the one that is easily reduced among the aqueous sodium and aqueous H plus ions, right? So between the fight of sodium and H plus ions, which wins the fight? H plus ions are winning the prize, right? So what the prize they are getting? Electrons. They are getting an electron and getting their form and change into a gas, which is hydrogen, right? So the H plus ion wins, right? So H2 gas liberates near the electrode. Therefore, the reduction process can be presented as follows: 2 electrons gains by the 2 of the hydrogens produces hydrogen gas. And this is a what process? This happens where? Cathode. This happens in the cathode and is a reduction, right? It's a reduction, right? A reduction. With electrolysis, the concentration of chlorine ions in the aqueous solution decreases, but the concentration of sodium ion does not change, isn't it? The Cl minus are right? Cl minus are reducing, but the sodium ions they remain same because they don't either increase or decrease, but relatively increasing because the other ions are reducing. The concentration of H plus ions decrease because H plus in the water decrease. Water molecules tend to dissociate continuously and give H plus ions. So now the H plus ions are removing. So as we discussed, under an equilibrium, if a change occurs for the equilibrium, it resets to evacuate the change, right? That means like if the H plus is reducing, the reaction produces more H plus ions, which is the dissociation reaction, which is water molecules breaking more into what? H plus ions and OH minuses, right? Right. So the concentration of H plus ion decreases because H plus ions water decreases. Water molecules tend to dissociate continuously and give H plus ions because of that, right? Reaction forward method. This causes the concentration of OH ions to increase. As 2 H plus ions are removed from the cathode, 2 Cl minus ions are oxidized and removed from the anode. At the same time, the dissociation of water molecules result in 2 H plus ions and 2 OH minus ions. H plus ions අයින් වෙනකොට OH minus සහ H plus ions water වලින් dissociate කර දෙනවා. As a result, the concentration of NaCl decreases and the concentration of NaOH increases as a result of the removal of dissolved Cl ions and the dissociation of water molecules to give OH ions. Now this is a complete reaction. What happens? NaCl dissolves. Water molecules break down into H plus and OH minus ions, and the H plus ions are removed as hydrogen gas, and the Cl minus are removed as chlorine gas. So what is left now? Sodium ions are left and the OH minus ions are left. So they become sodium hydroxide. Therefore, the overall reaction is as follows. What is the overall reaction? Sodium chloride plus H2O produces 2NaOH plus Cl2 plus hydrogen gas, right? So is it almost? Yeah, almost 8, right? Some of the Cl2 gas generated near the anode surface has the potential to dissolve in water and react with NaOH to form NaCl. Now this is an issue. Now Cl2 is produced. So produced Cl2 is reacting back with the produced NaOH. Do you understand it? The produced Cl2 can react back with the NaOH produced and produce a NaOCl, right? So this is a disturbance for the reaction, isn't it? Right? This isn't what we want, right? So this is a reaction unexpected, right? So we have to remove Cl2 carefully because it might will react with the produced sodium hydroxide. So there is something we have to do about it. If this reaction occurs, the amount of NaOH produced will decrease. NaOCl is formed as a waste product in the NaOH produced, right? In the production of caustic soda, the formation of NaCl in the reaction medium is a disadvantage, right? This can be avoided by separating the cathode and anode regions with a material that is permeable to the ions, right? Now there what they do is they are producing a permeable ion permeable layer, right? So in the ion permeable layer, now the ions are permeable to it. Now what happens here is what happens actually is only the ions are permeable here, so that almost all the ions will, like the sodium and the OH minus ions will accumulate here in the cathode region, right? It explains here, we'll show it and we'll come back to this. So since the Cl ion concentration in the anode chamber is low, Cl ions can migrate to the cathode chamber to the anode chamber initially. Now what happens? Cl ion concentration in the anode chamber is low. Why? Because all the Cl minuses are going there and escaping as chlorine. So in the anode chamber, if we separate the two of the chambers as anode and cathode, in the anode chamber Cl minus are less or more? Is less because it's escaping there. Cl minus are less. Since the Cl ion concentration in the anode chamber is low, Cl ions can migrate from the cathode chamber to the anode chamber. The cathode chamber and anode chamber එක ඒගොල්ලෝ එනවා. හරිද? මේකේ ඉන්න අය මෙන්න මේකට එන්න බලනවා. හරිද? ඇයි මේගොල්ලෝ මෙතනින් escape වෙ යනකොට මෙහි තියෙන්නේ මෙහෙට එනවා. මේ දෙක මාරු කරලා දාලා තියෙනවා නේ. මාරු කරලා දාලා තියෙනවා. මේ පැත්ත anode chamber එක. ඒතර cathode chamber එකේ නම් මේ Cl minuses මේ පැත්තට එනවා. හරිද? Right. Since the H plus ions concentration in the aqueous medium surrounding the cathode chamber is low, water molecules dissociate to give H plus and the OH ions concentration in that chamber increase. Because in the cathode chamber එකේදී මොකද වෙන්නේ? H plus ions අයින් වෙලා යනවනේ. ඒ හින්දා මොකද වෙන්නේ? අර water molecules dissociate වෙලා ඒ පැත්තේ H plus ions හදනවනේ. ඒතර H plus ions අයින් වෙනකොට OH minus මොකද වෙන්නේ? ඉතුරු වෙනවා. එතකොට එහෙනම් A chamber එකේ කියන්නේ cathode chamber එකේ මොනවද ඉතුරු වෙන්නේ? OH minus accumulate වෙනවා. H plus ions හද ඒගොල්ලෝ අයින් වෙනවා. OH minus ඉතුරු වෙනවා. ඒතර එයා accumulate වෙනවා. H plus and OH ion concentration in the chamber increases, right? Therefore, the NaOH concentration in the cathode chamber gradually increases. Due to this, the NaOH concentration decreases. Due to this, the NaOH concentration decreases due to the diffusion of NaOH from the cathode chamber to the anode chamber through the ion permeable wall. Then ion permeable wall එක ගහපු හින්දා දැන් අපි මේ ion permeable wall එක ඇත්තටම ගැහුවේ හරිද? cathode එකේ Cl minus අයින් වෙන්නේ anode එකේනේ. දැන් anode එක වෙන් කරාම පස්සේ මෙතනින් යන Cl2 gas එක මෙහෙට එනවද? එන්නේ නැහැ. හරිද? ඒ හින්දා මේකෙදි H plus ions අයින් වෙවි ගිහිල්ලා OH minuses accumulate වෙනවා. sodium ions ටික මේකේ මේ පැත්තේ තියෙන ඒවත් ටික accumulate වෙලා මෙතන ගොඩක් sodium hydroxide හදනවා. හරිද? හැබැයි හදන amount එක මොකද වෙන්නේ? වැඩි වෙනවනේ. වැඩි වෙනකොට වැඩිපුර තියෙන sodium hydroxide වල pressure එක වැඩි වෙනවා. එතකොට මෙතනින් ඒගොල්ලෝ diffuse වෙන්න බලනවා anode chamber එකට. get it? හරි. ඒගොල්ලෝ diffuse වෙන්න බලනවා anode chamber එකට. ඒක කචල් එකක්. හරි. Due to this, the NaOH concentration decreases due to the diffusion of NaOH from the cathode chamber to the anode chamber through the ion permeable wall. And the reaction between NaOH and Cl2 gas occurs in the anode chamber. Therefore, the following figure shows the basic elements that need to be considered when designing a reaction chamber. හරි. ඉතින් ඒක අපිට අයින් කරගන්න මොකද්ද කරන්න පුළුවන් කියන එක තමයි පල්ලෙහා තියෙන්නේ. It is called diaphragm cell. හරි. Diaphragm cell එකක් දානවා. This is because the cathode chamber and the anode chamber are separated by an asbestos diaphragm. මේ දාලා තියෙන asbestos diaphragm එක. This is because the cathode chamber and the anode chamber are separated by an since the liquid level are unequal, the anode chamber exerts hydrostatic pressure on the cathode chamber. Now listen. Then NaOH accumulate වෙන්නේ කොහෙද? මේ chamber එකේද මේ chamber එකේද? First one එකේ chlorine හැදෙන මේකේ accumulate වුණ තින් react කරන. Second one මේක තමයි NaOH accumulate වෙන්නේ. මොකද මේකේ chlorine නැහැ නේ මේකේ chlorine තියෙන්නේ. දැන් මෙතන ප්‍රශ්නේ උනේ මොකද්ද? මේකේ accumulate වෙන NaOH මේකට diffuse වෙනවා. ඒක නතර කරන්න මොකද කරන්නේ? මේකේ තියෙන water layer එකේ height එක වැඩි කරනවා. එතකොට මේ පැත්තේ water pressure එක මොකද වෙන්නේ? වැඩි. එතකොට මේ පැත්තෙන් diffuse වෙන්න ගියාම මෙයාගේ pressure එක වැඩි හින්දා මේ පැත්තට diffuse වෙන්න බෑ. ඒක තමයි මේ water level එක වැඩි කරලා දාන්නේ. නේ?
අර asbestos එක දාලා සම්පූර්ණයෙන්ම දෙක වෙන් කරලා තියෙන්නේ.
ඔව්. හැබැයි ඒක permeable. Ion permeable. හරි. Right. The hydrostatic pressure reduces the possibility of OH ions diffusing through the chamber into the anode chamber. Hydrostatic pressure එකෙන් තමයි ඒක නතර කරගන්නේ. By using a graphite anode, the Cl2 gas formed on the surface no longer reacts with the anode. If iron is used for this, Cl2 oxidize the iron to FeCl3. අපි මේකට graphite electrodes තමයි ගන්න. ඇයි iron වගේ electrode එකක් ගත්තොත් එයා Cl එක react කරලා FeCl3 හදනවා. So there will be trouble. The anode is depleted to Fe3+. Ions are added to the reaction medium as impurities. Similarly, the aqueous NaCl solution used for this purpose should be free of impurities වෙන්න ඕන. හරිද? ඒ කියන්නේ අපට carbon graphite තමයි electrode පාවිච්චි කරන්න පුළුවන්. sodium chloride solution එකත් impurities වලින් තොර වෙන්න ඕන නැත්නම් ඒ ටික accumulate වෙනවා. අරගොල්ලෝ අයින් වෙනකොට නේ. Especially if the ions such as calcium ion and magnesium ion are present in the alkaline medium, they are deposited as calcium hydroxide and magnesium hydroxide in the cell, the pipe system and around the diaphragm, causing the production process to be disrupted. නේ. So calcium hydroxide, magnesium hydroxide හැදුනාන් පස්සේ process එක disrupt වෙනවා. The new trend is caustic soda production is to use selective ion exchange membranes. හරි. මෙන්න මේ selective ion exchange membranes හදන එක තමයි new trend එක. හරි. Instead of the diaphragm cell method, this membrane has very fine pores. Negative ions are permanently bound to the pores. හරි. ඒ කියන්නේ දැන් අර diaphragm එක වගේ දාන එකට දාන්නේ මෙන්න මෙහෙම මොනවාද? selective ion exchange membrane එකක්. ඒකේ එක pore එකක් වටේට මොනවද තියෙන්නේ? negative ion charges තියෙනවා. එතකොට බලන්න මොකද වෙන්නේ කියලා. මෙතන reaction එක වෙනකොට chlorine gas එක යනවනේ මේ තියෙන anode chamber එකනේ. එතකොට මෙතන තියෙන sodium මොකද වෙන්නේ? මෙයා attract කරනවා. attract කරලා කොහෙටද යන්නේ? cathode chamber එකට යනවා. හැබැයි cathode chamber එකේ අයින් වෙන්නේ මොනවාද? hydrogen. hydrogen අයින් වුණාම OH minus නේ වැඩි වෙන්නේ. ඒ OH minus එකට මෙහෙට එන්න පුළුවන්ද? බෑ. ඇයි? minus minus repel වෙනවා. repel වෙනද මෙයා මේ පැත්තේ concentrate වෙනවා. එතකොට sodium ions ටිකත් මෙහෙට යනවා. මේ පැත්තේ OH minuses concentration එක වැඩි වෙනවා. එතකොට ඒ පැත්තේ NaOH produce වෙනවා. Right? This hole attracts positive ion, sodium ion. Negative ions are repelled and prevented from migrating towards the membrane. As soon as two Cl ions leave the anode chamber, the cathode chamber is charged to balance the charge. එතකොට Cl minus දෙක අයින් වෙනකොට ඒ balance එක හදන්න sodium දෙයක් එහා පැත්තට යනවා. හරි. two OH ions must migrate from the chamber, but they do not migrate through the membrane. අර හරිනම් මේක කියන්නේ Cl minus දෙක අයින් වෙනකොට හරිනම් two of the OH minuses මේ පැත්තට එන්න ඕන. ඒ එන එක මෙයා මොනා කරනවා කියලාද කියන්නේ? Two ions must migrate from the chamber, but they do not migrate through the membrane. Since two Cl ions are removed from the anode chamber, two H ions are removed from the cathode chamber at the same time as two OH ions are removed. Two sodium ions must be migrate from the anode chamber to balance the charge on the two OH ions. හරි. ඒතරේ balance එක හදන්න sodium ions cathode chamber එක පැත්තට යන්න ඕන. ඒ කියන්නේ H+ ions වල balance එක හදන්න sodium ions අනිත් පැත්තට යන්න ඕන. Sodium ions migrate from the anode chamber to the cathode chamber very easily through the negatively charged force. This mechanism also prevents NaOH from reacting with Cl2 gases. Right. So a brine solution is pumped into the anode chamber. Can anode chamber එකට තමයි අපි brine solution එක දාන්නේ. Now this side anode chamber එක තමයි brine මේ solution එක brine කියන්නේ salt water නේ. The brine solution is removed from the same chamber මේකෙන් දාන්නේ මේකෙන්මයි අයින් කරන්නේ. While water is pumped into the cathode chamber from one side, the aqueous medium containing NaOH is removed from the same chamber, making water out. Sodium hydroxide ගන්න පුළුවන් එකතු කරලා. මේකෙන් brine එක දාලා මේකෙන් brine එක එළියට ගන්නවා. මේකෙන් water දාන්නේ. හරිද? මේක brine එක මේක water මේකෙන් NaOH තමයි යටින් ගන්නේ. Right. So that's so far it. Now do the questions, majorly the essays, and the question bank I gave. I think I gave the industrial, right? Did I? I did. I did.
Chemical industry. Question bank.
දුන්නේ?
PCB.
අයියර 3 4 තිබ්බනේ.
ඔය ගෙදි microbiology, thermokinetics thermodynamics. ඒ තුන.
Natural products. Natural products එක industrial තිබ්බනේ.
Natural products එකේ heat එක.
I'll translate it. I'll give it. Right. So that's it. Now done and dusted. Do the questions after I give it, and till now do the past paper questions, PPCs, and so far finish as much as possible. Like, do we
Elasticity එකයි තමයි
biotic tissue culture, then the forest, අර ඊට පස්සේ සත්තුන්ගේ සිට් එක, so then the IT. අපි බයෝටික මේ වීක් එකේ අපි ඉවර කරමු පොඩ්ඩක් ශක්තිය එකේ වැඩිපුර ඇදලා ඉවර කරගමු. චුට්ටක් ලේට් වෙලා යන්න බලන් ඉන්න. තමයි. මේ සන්ඩේ චුට්ටක් පරක් වෙලා යන්න බලන්. asking to. It's almost 1:44.